members of our group are Joe, Fergus, Charles and Cam. We've been working together throughout the semester on a Robotics Studio 2 project where we control a UR3 to play chess. But currently, we generate the chess moves for the robot to play using Stockfish, an incredibly powerful chess engine. However, for this AI project, we are going to replace Stockfish with our own AI algorithm to generate chess moves and outsmart human opponents. Our engine will need to be able to generate the best move from any given position. The benefit of training an AI model for chess is the abundance of data available. There are terabytes of recorded chess games and a large selection of high-quality games that can be downloaded for free. The standard form for this data is a PGN file, which contains metadata tags and the moves that were made. From this data, we can extract each position of the game and analyze the impact of each move. Our project will consist of 2 stages. In the first stage, we will use an SVM, or support vector machine, to evaluate and select chess moves. Each input for the SVM will be a combination of the ball position, which will be a 192-bit piece-to-square index encoding of the chess position, along with additional bits for castling rights, en-passant possibilities, and whose turn it currently is. This board state will be combined with the candidate move features, which include the origin and destination of the candidate move, piece type being moved, and the move type flags like capture, castle, and promotion. From this input, the output of the SVM will be a single numeric confidence score of how good the candidate move is predicted to be in the position. To use the SVM, we will generate all the legal moves in a position, create an input feature vector containing the position encoding and the move encoding, score this move using the trained SVM, and select the move with the highest confidence score. The SVM will be trained to distinguish between good moves and bad moves by being trained on thousands of grandmaster chess games. The SVM classifier will be used to generate good moves as a starting point for stage 2, a deep Q network or DQN. The DQN will use an epsilon greedy strategy during its training to choose moves between SVM generated moves, random moves, and moves generated by the DQN itself. This will require the team to set up a training environment where the DQN can play many games of chess against itself. We believe that a reasonable criteria for determining our grade would be a credit lining up with an AI algorithm trained using either an SVM or DQN to make reasonable chess moves at the level of a beginner player. A distinction would be an AI algorithm trained using both methods at the level slightly above that of a beginner player. This model would also be evaluated against other chess engines and using precision, recall, and F1 score. A high distinction would have all the requirements of a distinction, but would also have the requirement of being at an intermediate level and being integrated onto the Universal Robotics UR3.